In this video, I'm going to do an example of finding the volume of a solid of revolution using disks. Now, later on, we'll learn another method called using washers, but for this problem, we're going to use disks. So let's consider the region R that's bounded above by this function, 2x plus 3, okay, below by the x-axis, on the left by the line x equals 1, and on the right by the line x equals 4. Okay, we'll call this region R. And let's find the volume of the solid generated when this region is revolved about the x-axis. So we're revolving around the x-axis here. So this region is going to sweep around the x-axis and sweep out a three-dimensional solid. Now I've tried to draw the reflected part down here, that gets below the x-axis, but really it's a three-dimensional solid, and I've tried to draw the picture as well as I can over here. It's not a very good drawing, but you can kind of picture the x-axis is sort of going straight through here. This top line here corresponds to the top line there. The bottom line here corresponds to the bottom line. But it's a three-dimensional solid. Now, to show you that we're actually using disks in this problem as opposed to washers or something else, let's draw in a little x right here on the x-axis. And if we were to make a rectangle, okay, straight above that, okay, then that rectangle would reflect below the x-axis down here. Okay, and notice, what does that become? Okay, if we take this region here, this rectangular region, reflected across the x-axis, it becomes a disk, okay, a really thin disk. I'll try to draw thin disk. Okay, that's not a very good drawing. But anyways, a disk is really just a cylinder that doesn't have very much height to it. So every disk has a radius, and every disk has a little height to it right here. But for this particular problem, you see that this rectangle, when it sweeps around the x-axis, it'll become a disk. Okay, now what is the volume of this disk? Okay, of course, the volume of a cylinder is pi r squared h. Okay, but what is the r and what is the h? Well, the h is the little height here, this little distance, and that corresponds to the width of this rectangle. Now we call the width of these rectangles delta x. Okay, so the h is just going to be delta x. Now what is the radius? Well, for this particular x value, the radius we see is this length right here, and that length is the height of the function. Okay, basically it's the function value. It's f of x, okay, or 2x plus 3. Okay, so what we have here is pi times r, but r is 2x plus 3 squared, times delta x, because h is delta x. Okay, now that's just the volume of that one little disk, okay, this disk right here. But how do we find the volume of the whole solid of revolution? Well, we end up having to use an integral. Okay, so the volume of our solid of revolution is going to be the integral from 1 to 4 of, now let's look at our formula here, it's going to be pi times 2x plus 3 squared, and the delta x becomes the dx. Okay, so if we figure out this integral, that will give us the volume of this solid of revolution. Okay, this formula really just gives you the volume of that one little disk. We think of our region here as just made up of a whole bunch of really thin disks. Okay, and we add up the volumes of those thin disks, and we take the limit as the width of those thin disks go to 0, we end up with an integral. Okay, so if you compute this integral, this will end up giving you the volume of that solid of revolution. So I'm not going to work this integral all the way out here, but let's just kind of get it started here. You can take the pi out front, and 2x plus 3 squared just means this. Okay, and if you FOIL this out, 2x times 2x is 4x squared. We have a 3 times 2x, which is 6x, and another 3 times 2x, which is 6x, so we get a 12x, and then 3 times 3 is 9. Okay, and then we can do the antiderivative. We get 4x cubed over 3 plus 12x squared over 2, which is really 6x squared, plus 9x, and we're going to evaluate from 1 to 4. Okay, now I did this on my own here. So plug in 4 and plug in 1 and subtract, and when I did it, I ended up with 201 pi. Okay, or as a decimal, that would be 631.46 and this is cubic units. Okay, we're talking about a volume of a solid of revolution.